This video is set up and designed to review the proper setup for Lab 3 vapor pressure in Chemistry 112. We want to really focus on a good experimental design, proper equipment setup, and that always leads to good data acquisition. Today we're going to be logging our pressure data onto what's called a data logger. This is the Pasco GLX. It's a blue data logging box. You'll see the technician using. It allows you to store the data, translate it to CSV type file, and then we can move that with a common flash drive over to the computer where we can turn it into Excel. With the blue box is the sensor interface, which also is usually blue. It's a little small blue box. It will directly plug into the data logger, or sometimes we can put an extension cord on it so we can move it away from the box in case we need to mount it on a lab stand, etc. That sensor interface will take voltage and current from the sensor and translate it into data that can be read by the computer. And it also kind of clues the data logger into what kind of sensor it's going to be reading today. And then the sensor itself is going to have some electrochemical. Maybe it's got a sensitive chemical tip. Maybe it's like a pH probe. Today our sensor just reads pressure. I think it does it by experiencing a little flex in a closed membrane, and it can experience the tension it feels as it gets under more pressure. Anyway, that will then be sent to the interface. In this particular setup, the pressure sensor is actually built into the sensor interface. So when you pick up that blue box, it has both the sensor and the interface together, and that again can be plugged into the box, or we're going to use it extended with the extension cord. So one of the key points you need to pick up from this video and this teaching here is the proper way to turn on the data logger. You first must plug in the interface before you apply power to the data logger. That way when the data logger turns on, it will find the interface, because the first command it has is go find any interfaces. If you haven't plugged it in yet, it won't return to that command and you won't be able to find your sensor. So, step one, make sure your sensor interface is already plugged into the data logging box before you plug it in, and watch how the technician follows that technique. Okay, so now we're going to put in the jack stand where we're going to build our apparatus. It's going to mimic the one on the left here. You got your jack stand clamps. You'll notice there's kind of an upwards and downwards way. See how it's got a cup up? If you look at it, it's like a C pointing up. That's the way you should put that in there. It'll be weight bearing. If you flip it over, the only thing holding your weight is just the screw. So there you go. Jonathan's making sure that it's C up when you put those clamps on. These are little finger clamps to hold everything tight. It's a hot plate. Now that has a thermocouple control to it. So right now he's putting together a stand, but that thing in his left hand, that orange wire, that's a thermocouple. About where his hand is the tip, and that's where it senses temperature. Once again, this hot plate has that same kind of idea. You don't want to have the thermocouple out when you turn on the hot plate. You want to make sure the thermocouple's already in the back of the hot plate. That way when you apply power to the hot plate, it searches for the thermocouple. So watch later, he's going to make sure that he's got that connected before he plugs it in. Now there's the lab jack. So our design here, it's easier to move the heat up, and now here he goes. He's thinking about plugging it in, but he goes, wait a second, I don't want to do that. I got to make sure my thermocouple's in first, we hope. Yeah, there we go. Thermocouple first. That's a key here. A lot of these things just have real simple microcontrollers. So when you apply power to them, they start running the program. First order of commands in the program is go find the sensor. And so if it's plugged in already, then when you plug in power and power is given to that hot plate, it's going to find the thermocouple. All right? So that's another important point to the order in which you do things. Now he's trying to mimic the setup that's on the left, and the key to that setup is there's a little plastic hose that connects the blue sensor, the pressure sensor itself, that's what's clamped in there on the left, to that, it looks like an orange cap in that round bottom flask. That's called a septa. It's an airtight septa. There is a fitting through that airtight septa, so the tube itself is completely sealed off all the way through the septa into the inside of the round bottom flask. Now our strategy here is to try and make sure that the length's just right so that tube doesn't get kinked. So, you know, if the orange fitting is too far away from the septa, it'll be stretched. And if it's too tight, it'll kink that little tube. And when you start to bend that tube over, it's going to open up the septa and it's going to leak. So the distance is important, and that's also why we suspend the whole thing and bring the heat to it and not try and move the round bottom flask down to the heat. So that's where a lab jack comes in. It allows you to move things to and from, in and out of the sensor. Now, there's a real important safety point coming up on the hot plate right now, and he's applying it. He still hasn't plugged in the hot plate yet. So what's really important now is that sensor, the thermocouple, the orange thermocouple, has to be placed in what you're going to heat up before you turn on the thermocouple hot plate and ask for heat. If the thermocouple is just sitting around on the table and then you just turn on the hot plate and say, oh, let's turn it up to 100, it won't sense the change in temperature. It has to be inside what you're heating up, so it feeds back to the hot plate. So thermocouple tip in what you're measuring before you turn on the hot plate and ask for heat. That way you won't safely overheat. You'll overheat the hot plate if you don't do it that way. So he now knows, oh, okay, I'm good. Thermocouple's in place. It's in the fluid. I have my orange wire connected to the hot plate. I'm ready to go. So he's good to do on that. Now he's bringing his round bottom flask setup. You can get a bit better view. Look at the septa now. He's going to bend it down. That does a little better sill that holds it on. Looky there. There's the tube inserted through the septa. So when we connect that to the pressure sensor, we can't kink the tube, so he's going to get the distance just right. So he's kind of sizing that up. Okay. Now the way that connects to the actual blue interface is there's a little rubber ring that seals it off. So when it plugs up into the interface, it's just a little half quick and click. The rubber ring will make an airtight seal. So when he wants to, he can connect that to the blue box. Now for heating purposes, we tend to keep that open, because while it's heating up the fluid, in this case on that right-hand side there, that's acetone. On the left, he's got water, so he's going to get them both heating back up to temperature. Actually, I think on the left he's got the mix going because he's already recorded the water earlier. But anyway, the one on the right, that's the acetone. But when you're bringing these up to heat, they need to be open so that they allow so that pressure doesn't really build up too much and you blow the whole thing apart. So what you want to do is you want to have an equilibrium flowing with the outside so that at the very end, you can just click that in there. Well, you're going to remove the heat, click that together so that it will create the vapor pressure. Start reading the vapor pressure. Then you're gonna just allow it to cool. So really, what we're going to read at that point is we're going to read the cool down. We're not going to read the heating up. Although when you graph it, it'll look like we read it as it heated up, but in essence, it's going to read from hot as it cools down and the vapor pressure drops, right? Now look at this setup. Here he goes. He's ready to apply temperature because everything's been plugged in already. The thermocouple's where it belongs. And so it's okay now to turn these things on and ask for whatever temperature you want, and they won't overheat. So now we're off to the races, going up to our temperature above 50, and that's where we're going to rejoin the process. Okay, now we think we're up to temperature. So what he's going to do is he's going to show you we're up. Look at the bottom temperature in there, Celsius, and it's about, there we go, about 51 degrees Celsius, and we are trying to get to at least 50, so that's good. It's about 84 kilopascals at that point. Okay, so now watch the technique. We're ready. He's going to start data logging here. He's going to remove the, he wants to start the data logging, so now it's recording temperature, pressure, and now he's connecting the tube, right? So now the vapor pressure that's present in that system is locked. It's a closed system, and it's now undergoing a temperature drop, and it's going to record the resulting pressure as the temperature drops, and that's how we get our data. Again, that's why it's nice to have the lab jack, because you can move the heat away from the tube without changing the little connector and kinking it and opening up the sill. So here we go. We're going to start data logging, see if he gives us a look at the data logging screen. So he's going to go over to the other set, and the same thing's going on. We're going to get the temperature. It's at 52, almost 52.9. Going to follow the same procedure. Move that. Now this is going to be good because you can see the data logging. He's going to take a minute and show you what the data logging looks like. Going to change over down to the data table, and then he's going to push go, and it's going to start recording temperature and pressure every 3 seconds. So you can see it logging now. See it? Every 3 seconds. Good. And then really at this point he should reach up there and snap that tube in there so that he can start recording the pressure. So when the experiment's completed, we're going to basically reach down. So that'll be here in a while. So I'll just jump ahead as if the experiment was done. He's going to, when the temperatures drop below 25, he's going to push stop recording on that same blue box that's in his hand. He's going to insert a flash drive in there. He'll activate file transfer from that graphing screen, which will transfer the data from the flash drive, from the GLX to the flash drive. He can then walk that over to a computer, plug it in, and get it into Excel, and you're off to the races. So let's summarize some things we learned from this lab that are generally applicable. 1, always plug in sensors on both the Pascal and the thermocouple before starting the experiment. Never turn on a thermocouple controlled hot plate without having the thermocouple in a position to feed the temperature back to the hot plate. Number 3, you saw that the stand clamps were positioned C up to bear the weight so that you're not trying to hold the weight with just the screw. Jack stands were used to move heat or flask into or out of the reaction without disturbing components you want to keep in place. That's the application of the jack stand. The best way to transfer heat from a hot plate to the flask you're trying to heat is using a heat transfer fluid. Today you saw that we were using water, but if you wanted to use sand or you wanted to use silicone oil, those will allow you to heat up above 100 degrees C. And this is better than trying to just place the glass directly on the hot plate for two reasons. One, it doesn't transfer heat very well. And two, it's very hard to position a thermocouple so it'll feed back properly. So we usually use heat transfer baths, or what we call heat baths, to transfer the heat. Well, I hope this has helped and you picked up some good lab techniques. I'll see you in the lab.